and we will come back over here to MLAB, knowing what's in our file now. And we want to get to the point of what we're really trying to do, which is read data. So let's imagine this file, our file.dat, is a data file. And we say Q is equal to read. This is the MLAB function that reads data from a file. And what it takes as input is the file name, our file, and you don't need the .dat because MLAB will stick a .dat on by assumption if you don't have any extension at all. And if you had an explicit file name you wanted to have with no sticking on anything of any kind, you just say the full truthful file name in quotes like that as a string. And then you say how many rows of numbers you want to read. And I want to read, let us say, 5 rows of numbers, and I want 3 numbers in each row, that is 3 columns. So I'm going to read 15 numbers as a 5 by 3 matrix, 5 rows by 3 columns. And that's what this command says. And where do those numbers end up going? In Q, in the matrix called Q.
So you're plucking out numbers from that 100 by 1
Yes.
list.
Yes, exactly. This is reading that file, and it's reading the first 3 numbers. There we are. There's Q. Let's take a look at Q. Type Q, and also just to compare, let's type M row 1 through 15. Okay, well, let's scroll back and look at this. Here is our 5 by 3 matrix Q. The first number is 100, just like we said before, and then 1, and then 1, and then 0.59, and then 2, and then 0.55, and so it goes. It is not the first 15 numbers in the vector M because of those line numbers being treated as actual data. Again, MLAB doesn't know anything except read the numbers in sequence. Ignore the letters, ignore anything that's not a number. Okay, so we have just read in this matrix Q. I'll just type it again, Q. There it is. And now what we can do is read in a whole big matrix if we want. Well, let's make another one. Q0 is equal to read of our file. Remember, we don't really need, we can get the .dat out of that. And we'll read 1,000 numbers in one column since we didn't say anything. And what's in Q? Well, let's check that. N rows of Q0, sorry, not Q, Q0. And 202 numbers are what was in that file. That makes sense because we had 100 random numbers and we have 100 line numbers, and then we had that little comment at the top, 100 by 1.
Right.
That's 100 times another 100 for the line numbers, plus 2 is 202,
So
and that's what it
up.
says. 202 numbers were in that file. Notice we said read 1,000 numbers, but that is just an upper bound. It says read at most 1,000 numbers and stop when you get to the end of the file. So there is a vector, a 1-column matrix Q0 that we have created. And now let's just compare a little bit about this. Let's do this interesting little calculation. Type out the following. Take the vector M, remember that's the random numbers that we first generated, and subtract from the vector M the vector Q0, the numbers we just read in, where we take the rows, row, parenthesis, 4 through 202 in steps of 2, close, and close the thing we're subtracting and close the expression we're typing out. And just, we don't want to look at all 202 numbers, so just look at row 1 through 4, and maybe row 50, and maybe the last row, n rows of Q0. Okay, and close. And see what Sorry, I don't want the n rows of Q0. I want the last row of this difference, which is going to be, to back up, n rows of M in this difference, and close. Okay, so this is a complicated statement. It says take the vector M of random numbers, take the vector Q0 we read in, extract from that, skipping the first three numbers, which was the 100, the 1, and the 1 of the line numbering. In other words, skip that whole first three numbers and start with 0.59. That's what will happen. Go all the way to the end of Q0, 202, but in steps of 2. So take the numbers in row 4, row 6, row 8, and so on, and subtract that set of numbers from M. It should be exactly M. So this should be 0. M minus the Q0 extracted out, that should be 0. A bunch of zeros, a list of 100 zeros, right? And now just look at the first 4 and the 50th and the last one just to see if they all are 0. Okay, so here we go. And they aren't 0. What are they?
They're close to it.
Well, very good. They are close to it. Minus 1.0894 ... times 10 to the minus 10th. Shift that decimal point 10 places over to the left. So very close to 0. These are all numbers very close to 0.
So very small, but not
0. Why aren't they 0? That is the thing about computers. Computers do not work with real numbers. Computers work with approximations to real numbers. In fact, stored in the matrix M, look at M row 1 through 4, and look at, let's line it up with Q0. I have to backspace. Okay, so look at M row 1 through 4 and concatenate column-wise. Ampersand prime joins another matrix as a second column. Q0 row, and you may recall, not row. Remember, it was 4 through, and I want to do 4 of those things. So 4 through 16, is it 16? No, I think it's 2, 16. So 4 through 16 in steps of 2 to get the exact matching numbers. Close. And I'm joining 2 little vectors, a sub of 4 numbers from M, the first 4 numbers of M, and the first appropriate numbers from Q0.
So is this creating a new matrix?
Yes, that outputs that matrix. There it is, output on the screen.